In this video, we're going to take a look at a proof of the derivative of a to the x. But before we do that, we need to recall some facts from pre-calculus. The first one is about the power property of logarithms, and the second one here will be very important for us to use. It states that if we have an exponential function base e raised to the natural log function, which is also base e, that this will simply become x. Since these are inverse functions, then when I take e to the natural log of x, we have x. And then from calculus, we know that the derivative of e to a power is the same as e to the power times the derivative of the power. So let's begin the proof. We are going to prove that if y equals a to the x, the derivative of a to the x is a to the x times the natural log of a. Let's begin by rewriting y equals a to the x as y equals e to the natural log of a to the x. So we're essentially using this property right here. Next, let's rewrite e to the natural log of a to the x as e to the x times natural log of a using the power property. Remember that the natural log of a is a constant. So now I'm going to take the derivative of e to the power, and the derivative of e to a power is e to the power times the derivative of the power. And since natural log of a is a constant, the derivative of x times natural log of a is simply natural log of a. So the derivative of e to a power is e to the power times the derivative of the power. And now we're going to undo what we did in the first two steps. So we'll rewrite e to the x times natural log of a as e to the natural log of a to the x using the power property. And then we're going to recognize that e to the natural log of a to the x is simply a to the x. So we've proven that the derivative of y equals a to the x is a to the x times natural log of a.